Hey class, this video is going to cover some right triangle trigonometry, section 11.1b. So our objective for this lesson is to use special right triangles to evaluate trigonometric functions of acute angles. Here's a reminder of the 6 trig functions that we're going to use. Remember the acronym for remembering the ratios of these trig functions is SOHCAHTOA. So SOHCAHTOA. But today our focus is going to look at some right triangle trigs. So this might really remind you of some things that you've learned in geometry. So we have 2 types of special right triangles. We have the 45-45-90 right triangle, which is the isosceles right triangle. And it's called that because the 2 sides are always equal because the angles are equal. So if the angles are equal, then the sides across from them are equal. The 45-45-90 triangle is special because it always has the same ratio. It always represents the ratio 1 square root of 2. So the side lengths are always the same size, and the hypotenuse is always the square root of 2 times as large as the side length or the leg. So the ratio 45-45-90 always follows this kind of equation where the legs are the same, so we could call those x, and then the side across from the 90, or the hypotenuse, is always x times the square root of 2. So the legs are always equal in the 45-45-90. And that brings us to an equation that we can write. We could say that we could find the hypotenuse by taking the square root of 2 times the leg. So if you have a 45-45-90 triangle that you're trying to solve for, you're either going to be multiplying by the square root of 2 to find the hypotenuse, or if you need to solve for the leg, you're going to be dividing by the square root of 2. So, because if you have this formula, then you could say that the leg would be the hypotenuse divided by the square root of 2. So either way, square root of 2. For the 30-60-90 triangle, we have 3 specific parts that have this ratio. So the 30 degree is always the smallest side. So this is, we call the short side, and it has a ratio of 1, or short leg, I mean. The side across from the 60 is the square root of 3. So it's square root of 3 times the short leg, and that one we call the long leg. And then we have the hypotenuse, and the hypotenuse is 2 times the short leg. And so that's the hypotenuse. So the ratio for 30-60-90 is 1 square root of 3, 2. And our formula then becomes, well, if our 30 degrees are x, then the long leg, or the hypotenuse, is 2 times the short leg, and the hypotenuse is the square root of 3 times the short leg. Or I suppose we would write that as x square roots of 3. So then we have a couple ways to remember that. So you could say that the long leg is equal to the square root of 3 times the short leg. Just use SL, short leg. And the hypotenuse is equal to 2 times the short leg. So since the long leg and the hypotenuse is both being used both using the short leg, it's always best to find the short leg first. So let's practice this a little bit. So we'll find the missing side lengths. The first one we have is a 45-45-90 triangle. So we know that the legs are the same. So if this leg hypotenuse, if this leg is 5, this leg is also 5. Then we know that the hypotenuse is the same thing as the square root of 2 times the leg. And so if the hypotenuse then is square root of 2 times 5, or 5 square roots of 2. This is x, this is x, this is x square roots of 2. So if x equals 5, then the hypotenuse is 5 square roots of 2. For the 30, 60, 90 triangle, our ratio is the across from the 30 degrees is our x. The hypotenuse is 2 times the short leg, and the 60-degree side is the square root of 3 times the short leg. So if we know that the long leg is 12, then we have to know that the short leg is 6, because it's going to be half of that. So the ratio 30, 60, 90 is x square roots of 3, and 2x. I know that 2x is equal to 12. So if 2x equals 12, I can solve for x by dividing by 2 and get x equals 6. Once I know that x equals 6, then I know that the long leg, or the side across from the 60-degree angle, will be 6 square roots of 3, because it will be, the long leg will be the square root of 3 times the short leg. So long leg is 6 square roots of 3. And the hypotenuse is 2 times the short leg. And I knew the hypotenuse was 12, so 2 times the short leg has to be 6. So different ways of solving it. So we had 12, 6 square roots of 3, and 6 are my 3 side lengths then. You can always check your answer by solving the Pythagorean's theorem. If you did a squared here, b squared has to equal 12 squared. So you could check your answer using that Pythagorean's theorem as well. We'll do a couple more examples. So 45, 45, 90. My main equation, I know that my leg equals my other leg. So leg equals leg. And then I know my hypotenuse equals the square root of 2 times my leg. So the legs are the ones that are across from the 45-degree angle. So if this side is 9 square roots of 2, then this side over here is 9 square roots of 2 as well, because leg equals leg. They're always equal. And then my hypotenuse will equal the square root of 2 times my leg, which was 9 square roots of 2. So then I can multiply this together. When you multiply with roots, you multiply the coefficients on the outside. So this is 1 times 9 would be 9. And then you multiply what's on the inside together. 2 times 2 is 4. So that's 9 times the square root of 4. And the square root of 4 is 2. So 9 times 2 is 18. So that tells me my hypotenuse is 18. Okay. For the 30, 60, 90 triangle, I have 2 equations. I know that the long leg is equal to the square root of 3 times the short leg, and I know that the hypotenuse is 2 times the short leg. So it's best interest to find the short leg first, since both of those are related to the short leg. The one across from the 30 degrees is the short leg, across from the 60 degrees is the long leg, and the across from the right angle is the hypotenuse. So since we were given the hypotenuse, we're going to have to start with my second equation here. Plug in 8 for hypotenuse, and it's going to be 8 equals 2 times the short leg. So I know my short leg has to be 4 then. I can find it algebraically by dividing both sides by 2. So my short leg will be 4. And now if I have my short leg, I can find my long leg, because it's going to be the square root of 3 times 4, which is going to be written as 4 square roots of 3. So 4 comes out on the outside and multiplies with that 1. So the long leg is 4 square roots of 3. So now I've solved that triangle. So solving a right triangle, remember that means to find all the missing lengths and angle measurements. We want exact answers because this is a special right triangle. If I have 30, 60, if I have 30 and 90, that gives me 30 plus 90 is 120. And remember that they have to add up to 180. So that leaves me with 60 degrees left for angle B. So measure of angle B is going to be 60 degrees. This is the measure of angle A, and this is the measure of angle C. So now I have a special right triangle. So I could use my SOHCAHTOA to find the side lengths of A and C, but it would give me decimal answers, and I wanted you to give me exact answers. So we're going to use the special right triangle ratios to find it. So again, we have two formulas for a 30, 60, 90. We have that the long leg equals the square root of 3 times the short leg, or we have the hypotenuse equals 2 times the short leg. So my short leg is going to be across from the 30 degrees, so this is going to be my short leg is A. Across from the 60 degrees is my long leg, and across from the 90 degrees is my hypotenuse. And that's always the case. So it looks like I'm given the long leg, so I'm going to start with the equation here on the left. I'm going to substitute 7 in for the long leg, and then that's going to be the square root of 3 times the short leg is A. So now I want to solve for A, so I'm going to divide both sides by the square root of 3. We get 7 over the square root of 3 equals A, and then I'm going to need to rationalize that because we can't leave a square root in the denominator of a fraction. So I can rationalize that or make it a rational number by multiplying both the top and bottom by the square root of 3. So that will simplify to 7 square roots of 3 over 3, and that will equal A. So A will be 7 square roots of 3 over 3. And now I have enough information. Since A was my short leg, I can plug it into my hypotenuse equation. So now I know that the hypotenuse will equal 2 times the short leg. The short leg was 7 square roots of 3 over 3. So to multiply a whole number by a fraction, you might want to put the whole number over 1. And then remember, you multiply across the top and then across the bottom. So across the top, 2 times 7 square roots of 3, since 2 is on the outside of a square root and so is 7, you multiply those coefficients together. So 2 times 7 is 14. The square root of 3 goes along with it. And then on the bottom, 1 times 3 is 3. So that means my hypotenuse, which was my C value in my diagram, will be 14 square roots of 3 over 3. And now I have solved the everything for this triangle in exact values. If you would have used the trig functions like we did in the last lesson, you would have gotten the decimal answers. So when might you use some trig? It's done a lot in construction and building, finding the, like in blueprints, you're going to use trig to find angles and side lengths and so forth. So here's a very starting value for, or a starting example for using trig to find a height. You measure a flagpole, you stand 20 feet from the base of the pole. The angle of elevation from the point on the ground to the top of the pole is 65 degrees. Find the height of the pole. So I'm going to draw myself a picture. I have a flagpole and I'm standing 20 feet away from it. So I'm standing over here. This is my flagpole. So this distance is 20 feet. The angle of elevation, so that's from where I'm standing, so elevated to the top of the pole, that angle is 65 degrees. And I need to find the height of the pole, which is going to be X then. So if I look at 65 degrees, I'm searching for the opposite side, and I've been given the adjacent side because I'm assuming that the pole and the ground are meeting at a 90-degree angle. So which trig function, if you think about SOHCAHTOA, which trig function uses the opposite and the adjacent sides? That would be tangent. So I could set up an equation that says that the tangent of 65 degrees will equal the opposite side, x, over the adjacent side of 20. And now I can solve this equation for x by multiplying both sides by 20, because divided by 20 and multiplying by 20 are inverse operations. So that will leave me with x equals, and 20 times the tangent of 65. Again, remember that your calculator must be in degree mode or it will give you the wrong answer, is going to give me 42.9 feet approximately. So I could say the height of the pole is approximately 42.9 feet. So if you did this in radians, like your calculator is in the wrong mode, I think it would give you an answer that probably doesn't make sense. So make sure to check it. Okay, that's all I have for this video. Thanks for watching.